Okay, this is Chapter 6, Lesson 1, Relations and Functions. We are getting into linear equalities and functions, and I know that sounds really difficult, but it's really not. It's a lot of big words, so these are going to be, some of this is going to be new to y'all. Maybe you learned it in 6th grade. It is graphing, so it is a little bit more time-consuming, but it doesn't mean it's hard. Time-consuming does not mean hard. It means tedious, maybe, to you. So, relations and functions. Hey, big girl. This is the only way I can record a video right now, as if I'm sitting on the floor, so I apologize. So, Jose studies the effects of global warming on an animal population. Some of his collected data values are in degrees Fahrenheit and some are in degrees Celsius. Jose wants to provide all of his data in degrees Celsius for consistency. How can he relate the two systems to do this? So I noticed that, I'm sure y'all noticed that there's these little 3 pictures that you probably are trying to read and can't. One way is using a table, and the other way is using a mapping diagram. To relate the two systems, write each Fahrenheit value as a Celsius value using the conversion formula. And the conversion formula is right here. Then pair or map each Fahrenheit temperature with the Celsius temperature. Use a table or mapping diagram. So this is what a table looks like, which you're aware of. They have the Fahrenheit, and then this is the equation. And all they did was plug in the Fahrenheit. So when Fahrenheit's 212, the Celsius is 100. When Fahrenheit is 98.6, the Celsius is 37. When Fahrenheit is 32, the Celsius is 0. When Fahrenheit is 0, the Celsius is negative 17.8. And all they did was plug in Fahrenheit into the equation to get Celsius. So, after that, using a mapping diagram, it's just, it's just another way of showing how they can relate the two systems. So, making this bigger for y'all to read it. This is basically what I said. This pairing and mapping produces a relation or set of ordered pairs written as Fahrenheit Celsius. So here's what I want you to do. I don't want you to copy down. I want you to understand your definition. So you need to write down all the highlighted words and write a definition for each of them. You can use the definition if you understand it on this page. So tomorrow when I check your notes, I need to see your definitions. I'm going to be looking for each of them. So a relation is a set of ordered pairs. The domain is the x coordinates or input values are called the domain. So when they talk about the domain, they're talking about just simply the x values. What is the domain? It's the x values. The range is the y coordinates. So those are the y values. It's the output values. And a function is a special relation. Each element of the domain input is paired with or mapped onto exactly one element of the range. And the different output, that is, no two ordered pairs have the same first element and different second elements. So what it's trying to say is that you cannot have the x coordinates repeating. That's all it means. A function means the x coordinates do not repeat. So for example, you can't have 1, 0 and 1, negative 1 as 2 points. Or else it's not a function. Hey girl, where are you going? Where are you going? Oh, did you get it? Okay, so it says, determine whether each relation is a function and explain. Well, I just told you right before you saw my cute little baby crawling around that a function is, you can't have the same x coordinates repeating. So I want you to look at number 1 and number 2. Determine whether each relation is a function and explain. Well, number 1 has coordinates. For a function to be a function, that means that the x coordinates do not repeat. So I only need to look at the x values. So I have oh gosh, she's moving a lot. -2, -1, 0, 1, and 2. Do any of those repeat? No. So, oops, I don't need to write no. That means it is a function. Yes, it's a function. Domain values don't repeat, meaning the x values don't repeat. Okay, so number 2. It would probably help if you had this in your notebook as well, so you have something to look back on whenever you're doing your assignment tomorrow. Number 2, I have my x values are 0, 1, 1, 4, and 4. I have 2 1s and 2 4s. That means it's repeated. That means it's not a function, so no. And you can say there's a repeating of 1, repeating of 4, which means that it's not a function. So if a function is specified by a rule or an equation, you can use the function notation f of x. Okay, I really want you to make this clear. This is what's very, very, very important. F of x, read f of x, is equal to the y coordinate of a given value x. It indicates the substitution of an x value to find its corresponding y value. Okay, so that can make perfect sense to you, or that can be complete gibberish because of the way they worded it. F of x means it's just, that's what y equals. F of x equals y. The x value, so right here if you read f of x, oops, I should probably make it a different color. F of x, it's in parentheses, equals 3x minus 4. Find f of -4. That means where x is, I plug in a -4 into my equation. And I told you f of x equals y. So y will equal 3 times -4 minus 4. So that's the same thing as saying f of x will equal 3 times -4 minus 4. So 3 times -4 is -12 minus 4. Subtracting negatives and positives, same signs add, oops, different signs subtract. So that means that they're different signs. Oops, just kidding. That's only if you're adding. What am I thinking? -12 minus 4. I have to keep flip change. Subtraction, I have to do keep flip change. So I have -12 plus -4. Okay, so I have -12 plus -4, which is -16. So that means when x equals -4, y equals -16. So that is my point. Now you've got my hair. Okay, so I want you to try number 2. And again, f of x means y. That's what your y is going to equal. And all you do is plug in your 6 value where your x is. Okay, so if f equals 6, if f of x is f of x equals -x squared, find f of 6. That means I'm plugging that into my equation. So f of x, remember f of x just equals y, always. So I'm going to rewrite it as y equals -x squared. So I'm going to put -6 squared. -6 squared is -6 times -6. If you're typing it in a calculator to check your work, you need to put your 6 in a negative. In a parentheses. So -6 squared is -6 times -6, which is positive 36. So when f is x equals 6, y equals 36. So that's how you would write it, as an ordered pair. Okay. So a relation can be represented by a graph. To determine whether a graph of a relation is a function, you can use the vertical line test. This key concept is something that you need to know. A vertical line test for a function. If each vertical line drawn through the graph of a relation intersects the graph in at most one point, the relation is a function. So graphs A and C represent functions because each vertical line drawn through each graph intersects the graph at exactly one point. Graphs B and D do not represent functions because a vertical line drawn through each graph intersects the graph at more than one point. So For example, right here, if I drew a vertical line, that's a vertical line through one of the points, that means that my x values are going to be repeating. Because right here, it's going to be the same x values throughout, which means it's not a function. Right here, I have two parts that repeat, x right here and x right here, meaning that because it repeats, it's not a function. Here I won't have any of the same x values, and right here I won't have any of the same x values. That's all that means. Okay, so write the domain and range of each relation. Is each relation a function? And explain. Okay, so number 1, 2, and 3, your domain is your x values. So you would simply write, I'm going to do number 1 with you. Oops. Domain domain equals, and then you would put a parentheses equals, if I look here, my domain is 4, 4, 4, 4, so I would put domain equals 4. If I had a different number, so if it was 4, 0, then 2, 1, then I would put the 2. So domain equals 4, and that's it. So number 2, hey, that's my book. Number 2, your domain would equal 0, -2, -3. I'm just doing my y value, my x values, and -4. And I completely forgot to put the range of my other one. So my range equals 0, 1, 2, and 3. That is my range of number 1. So number 2, I don't have room, but it just happens to be my range is also 0, -2, -3, -4. So I want you to do number 3. And I want you to also do number 5. And that's the only 2 numbers I want you to do. If you did not understand a certain definition, tomorrow when you come to class, I want you to have those questions ready for me. Because if you don't understand the definition, chances are you're not understanding this lesson. So I hope you enjoyed, and I hope my daughter wasn't too much of a distraction like she is to me. Oh, yeah. And I hope that that you don't ever have to go through a baby eating your hair. All right. Say bye, Reese. Say bye. Can you wave to them bye? Can you wave to them bye? No. Oh, no.